Should have given better instructions on 42, 43, and 44, but these are solving systems. Okay, and this first one is set up for substitution. So you'll see I have y equals 2x. So I'm going to replace y with 2x. So instead of y, I'm going to write 2x minus x equals 4. And then remember, on this side, I'm going to write the other equation, my substitute equation. And I'm going to solve this because I only have x's left, so I can solve for x. So this gives me 4x minus x equals 4. Well, 4x minus x, it's like saying minus 1x, gives me 3x equals 4. So divide both sides by 3. And I get 4/3. So my x is 4/3. So now, using my calculator, I'm going to plug in 4/3 for x. So y equals 2 4/3. And then I can type that in my calculator. I always want to do it as a fraction because if I do it as division, it's going to give me an ugly decimal. And I get 8/3. And then remember, we can double check our work. I'm going to plug it into this bottom equation because I just plugged it into the first equation. Okay, so 2 times y is 8/3. That's a z. 2. Dang it. If I can type it. 8/3 minus x, which is 4/3. I should use parentheses, but on this one it'll still work. And it should equal 4, and it did, so I did it correctly. Now this one is also set up for substitution because I have an x alone. So I know x equals 2y minus 1, so I'm going to replace x with 2y minus 1. So I get 4 parentheses 2y minus 1 minus 3y equals 21. And then remember, on that side, I bring over my substitute equation. So I get 8y minus 4. Bring down my minus 3y equals 21. Well, I have like terms. 8y minus 3y is 5y minus 4 equals 21. So I'm going to do plus 4, and I get 5y equals 25. Divide by 5, and I get y equals 5. So I know that my y, which is the second part of my solution, is 5. Because remember, this is x, y, x, y. And so now I'm going to plug in y is 5 here. And I get x equals 2 times 5 minus 1. And I can literally type that on my calculator. And I get x equals 9. And again, I can check my work. So I just plugged it into that first one. Let's plug it into the second one. 4 times 9 minus 3 times 5, and that should equal 21, and it did. So this is my answer. Okay, last one on this section is 44, and it's set up for a big addition or elimination. I'm going to rewrite it in a second, but I have to either cancel my x's or cancel my y's. And these look both super simple to cancel because I know this is 1. 1 times 2 is 2, and then 3 times 2 is 6. So I can multiply either equation to make this cancel. I'm going to go ahead and cancel the x's because that just keeps my number. Well, I guess they'll both keep my numbers pretty small, but whatever. So I'm going to multiply this one. So I'm going to rewrite that top one. 2x plus 3y equals, I'm assuming that's 10. I hope. Okay, so now, hold on, I'm going to look. Yeah, I think it's 10. Okay, to cancel my 2x, I need a negative 2x. Well, how do I turn a 1x into a negative 2x? I'm going to multiply by negative 2. Negative 2 times 1x gives me negative 2x. Negative 2 times 6y gives me negative 12y. And negative 2 times 32 equals negative 64. And now we get to set it up as big addition. Well, my x's cancel. I have 3y plus negative 12y. Well, 3 minus 12 is 9. Yep, negative 9, sorry. Equals, and that gives me negative 54. Divide by negative 9, divide by negative 9. and I get y equals 6. So I know y is 6. Now, to find x, I pick either equation and I plug it into the original. So I'm going to pick the bottom one because it's x is 1. There's going to be no dividing. So I have x plus 6, and instead of y, I'm going to put 6 equals 32. This gives me x plus 6 times 6 is 36. I don't know why I second guess myself on that. Minus 36 minus 36. So I get x equals 32 minus 36, which gives me negative 4. And I can plug it into both to double check my work. So 2 times x is negative 4, plus 3 times, oops, forgot my plus, 6. This should equal 10, and it worked. Okay, and then the second one is an x plus 6 times 6 should equal 32, and it did, so we did it right.